Here I want to describe the practical application of the idea of electromagnetic waves moving at the speed of light. This is kind of a subtle concept, but the practical application is the idea of using these to transmit and receive radio waves. So this is not simply just the radio waves that you listen to, but also cell phones, radar, any kind of signal transmission like that. Once again, the core of this is this oscillating circuit with a capacitor and an inductor. The frequency is related to 1 over square root of LC. And then I have a couple examples of some simple radios to show you that just hopefully illustrate this is really all there is to it. So if you've ever seen a crystal radio set, the inductor is just this coil of wire. The tuner in here is a adjustable capacitor, which is sort of a blown up version. As you turn the dial, you're actually really turning plates. As you turn the plates, you change the capacitance. Slightly more complicated, antique radio. If I take away the cover and look inside once again, the tuner is a variable capacitor. Over here in the back, this loop of wire is the inductor. Everything else is used to amplify the sound of the radio. So what is happening? What kind of a wave are we talking about here? To answer that, if we look at some of the different kinds of radio stations, some of the popular radio stations in Albany are 980 AM, 106.5 FM. I'm sure there's plenty of others. This number means if it's AM, this is 980 kilohertz. Or 980,000 cycles per second. What this is talking about is the carrier wave. A transmitter or a receiver receives a carrier wave with that frequency. If it's AM, this means amplitude modulation. So on top of that carrier wave, the signal gets larger and smaller. And this oscillator is essentially used as a filter to pull that out. And so you have an antenna and a ground, or essentially the same idea as taking the plates of the capacitor and pulling them outward. One's an antenna and one's a ground. To hear the sound, we put in the simple case, we put in a diode, and then a speaker, and then in the more complex case, you have some additional circuitry to amplify the sound. Anyway, the carrier wave to hear 980, I think it's a sports station, filters out this carrier wave. Amplitude modulation means you make the wave a little bit bigger and a little bit smaller. So that extra a little bit bigger and a little bit smaller drives the speaker. FM means frequency modulation. This is a much bigger frequency. This is actually 106.5 megahertz, or 106,500,000 cycles per second. And there, once again, you have that same carrier wave, but instead you are making little changes to the frequency. And so the circuitry is designed to find those little changes to the frequency and then amplify that signal. And then I'm going to leave it up to you to look up what XM means. But hopefully this brings you some perspective. Normally the inductance is set by the number of turns in the coil. and then you change the frequency or you tune the radio normally by changing the capacitance. With these old radios, you have big chunky circuit elements, modern radios, cell phones, that kind of thing. It's all digital electronics and becomes much more complicated, but this is still the basis.